Right now, at this very moment, we are facing a situation that NASA never prepared us for. The interstellar visitor that astronomers have been tracking for months, the object known as 3I Atlas, has disappeared. It did not gradually fade from sight as it moved away from the Sun. Instead, it vanished abruptly from all detection systems in a way that violates every known principle of orbital mechanics. What makes this event even more unsettling is that the disappearance occurred precisely at the moment scientists had predicted it would exhibit extraordinary behavior. Let me explain what is taking place, because the implications extend far beyond ordinary astronomical curiosity. When 3I Atlas first entered our detection range earlier this year, astronomers around the world celebrated the occasion. It marked our third confirmed interstellar visitor, a rare opportunity to study an object from beyond our solar system with far more advanced instruments than those available during Oumuamua's brief appearance in 2017. We tracked it carefully as it sped toward the Sun at over 200,000 kilometers per hour. Scientists measured its strange deceleration, recorded its impossible trajectory alignment with the solar system's ecliptic plane, and analyzed its hollow internal structure, which completely defied traditional cometary physics. Everything appeared normal until October 29, 2025. That date marked 3I Atlas's perihelion, its closest approach to the Sun at roughly 1.36 astronomical units. For context, that placed it just inside Mars's orbit, where it was exposed to extreme solar radiation and gravitational stress. This was the critical test astronomers had anticipated for months. Under such intense thermal stress, most comets either fragment catastrophically or develop brilliant tails as volatile materials erupt into space. Every major observatory had been prepared to capture this moment, but here is where the story takes its disturbing turn. As 3I Atlas passed behind the Sun from Earth's perspective, entering a predictable observation gap that would last several weeks, something changed. When the geometry once again allowed telescopes to track the region where it was expected to reappear, continuing along its calculated trajectory, the object was simply gone. Multiple observatories confirmed its absence. The James Webb Space Telescope detected nothing. Ground-based radar arrays received no signals. The European Space Agency's tracking systems reported empty space, where an estimated 33 billion tons of matter should have been traveling at precisely known velocities. Before we resort to speculation, we must consider the conventional explanations, because that is what true scientific inquiry demands. Could 3I Atlas have fragmented so completely during perihelion that the resulting debris became too small and dispersed to detect? That is theoretically possible. Solar heating produces immense thermal stress, creating temperature gradients that can reach hundreds of degrees across a rotating nucleus, generating powerful mechanical forces capable of tearing weak materials apart. We have seen this happen with many ordinary comets. However, fragmentation leaves unmistakable evidence. Expanding clouds of debris, persistent dust trails, and small fragments that follow predictable, traceable paths. The Hubble Space Telescope can resolve objects smaller than a city block at interplanetary distances, yet exhaustive searches of the predicted trajectory zone have revealed nothing, no dust, no debris, no remnants of any kind. It is as though 3I Atlas simply ceased to exist the moment it left our view. A second explanation involves possible trajectory miscalculation. Perhaps our predictions were inaccurate, and the object re-emerged on a different path outside our search regions. But this runs into serious mathematical problems. Astronomers tracked 3I Atlas continuously for months before perihelion. Its position, velocity, and acceleration were measured with extreme precision by multiple independent observatories. Those calculations included relativistic effects, solar radiation pressure, and gravitational influences from every major body in the solar system. The margin of error was minimal, mere hundreds of kilometers over interplanetary distances. To completely lose the object would require a trajectory shift orders of magnitude larger than any natural process could produce. This would be equivalent to a mountain-sized object suddenly changing direction toward Jupiter instead of continuing outward. Such an event does not occur naturally. This brings us to the third and most controversial explanation, the one that Harvard astrophysicist Avi Loeb has warned about since his initial analysis of 3I Atlas's strange deceleration. What if the disappearance was not an accident? What if perihelion represented the moment when a deliberate course alteration occurred, hidden from observation by the sun's blinding glare? Let us examine the physics behind that possibility. The Oberth effect, named after German physicist Hermann Oberth, describes how applying thrust at the lowest point of a gravity well, when velocity is highest, produces a dramatically greater change in final trajectory. It is the most efficient moment to perform a maneuver. October 29th, the date of perihelion, represented the deepest point in the sun's gravity, well within billions of kilometers. If 3I Atlas possessed any form of propulsion or energy reserve capable of producing thrust, that would have been the ideal time to use it. A relatively small velocity change at perihelion could transform its escape path into a stable orbit, effectively turning a temporary visitor into a permanent resident of our solar system. Alternatively, it could redirect the object toward a specific destination, perhaps the asteroid belt, or the outer planets, where it might continue undisturbed observation. The timing appears deeply suspicious, or it may be yet another improbable coincidence added to an already troubling pattern. Our observation systems went dark precisely when such a maneuver could have occurred, hidden behind 1.4 million kilometers of blinding stellar plasma. And when the object should have reappeared, it was gone, as though it had deliberately used that blind spot to vanish. Consider its earlier behavior, because the pattern implies intention rather than randomness. 3I Atlas entered the solar system aligned with the ecliptic plane to within only 5 degrees, a geometric coincidence that occurs less than twice in every 100 random entries. Between September 23rd and 26th, it exhibited measurable deceleration, slowing from 68.2 to 67.9 kilometers per second behavior no natural process can explain. Density analyses indicated a hollow interior, a structural characteristic that makes no sense for a naturally formed body, but perfect sense for an engineered object designed to maximize internal volume while minimizing mass. It survived a direct coronal mass ejection that should have completely destroyed any loosely bound aggregate of ice and dust. It maintained rotational stability at a level natural tumbling bodies never achieve. And perhaps most remarkably, it executed a precision flyby of Mars on October 3rd, passing within 29 million kilometers, timed with such precision that the probability of random coincidence calculates to less than 1 in 50,000. Each of these anomalies could, on its own, be explained through imaginative extensions of natural physics, perhaps an unusual chemical composition here, a fortunate geometric alignment there, or a sublimation process yet to be documented, but taken together, they form a distinct pattern. And in nature, patterns often indicate underlying order, whether through physical laws we already understand or through deliberate design that we are only beginning to recognize. The disappearance of 3I Atlas marks a turning point, something fundamentally different from the mysteries surrounding Oumuamua. Yes, that first interstellar visitor behaved strangely, accelerating away from the sun without visible outgassing to account for the thrust. Its elongated form and unusually high albedo led researchers such as Avi Loeb to propose artificial origins. Yet, despite the controversy, Oumuamua followed a consistent hyperbolic trajectory. It arrived, displayed its peculiar acceleration, and then departed along a track that remained calculable and observable until it became too distant and faint for our instruments to follow. 3i Atlas has done something entirely different. It did not gradually fade from detection as it receded into the void. It vanished abruptly at the exact moment it should have been brightest and most active, emerging from perihelion heated, energized, and potentially displaying a dazzling tail visible to the naked eye. Instead, astronomers are now staring into empty space, confronting questions that threaten to unravel the very framework of modern astronomy. The institutional response to this disappearance is revealing because it mirrors patterns we have witnessed before. NASA's official communications remain cautiously neutral, emphasizing the necessity for complete data analysis before any conclusions can be drawn. The European Space Agency acknowledges the detection gap, yet maintains that total fragmentation remains the most plausible explanation. Meanwhile, China's space program, whose Tianwen-1 Mars orbiter had the optimal viewing geometry during the critical flyby, has continued to withhold detailed images and analytical reports. This silence feels familiar. When Oumuamua crossed our solar system in 2017, certain spectroscopic readings and radar observations were delayed or classified for months. When 2I Borisov appeared in 2019, similar delays hindered the release of comprehensive datasets. Now, as 3I Atlas performs its vanishing act, the information flow tightens again, as though an invisible valve is being deliberately turned. Perhaps these pauses arise from ordinary bureaucracy, government inefficiency, instrument recalibration, or a cautious reluctance to release extraordinary findings before verification. But the pattern is becoming difficult to dismiss as coincidence. Each time an interstellar visitor defies our scientific expectations, official channels grow quieter. That silence itself begins to function as a kind of message, a signal expressed through absence. To me, as a theoretical physicist who has spent decades exploring the universe's strangest possibilities, this does not signify conspiracy in the conventional sense. It represents something more deeply human, institutional caution in the face of the truly unknown. It reflects the fear of public panic, of speculation spiraling beyond control, of acknowledging something that refuses to fit neatly within accepted models. Yet science cannot advance if fear dictates the limits of inquiry. If 3I Atlas fragmented naturally, we should detect the remnants. If it altered course through exotic but still natural means, those mechanisms should be measurable and reproducible. And if neither explanation fits, if we are confronting something beyond current scientific understanding, then we have a responsibility to pursue that truth with integrity, no matter how uncomfortable its implications may be. The next several weeks will be crucial. Global observatories are scanning the regions where 3I Atlas might have redirected itself. The James Webb Space Telescope is dedicating valuable time to surveying areas where natural, gravitational, or thermal perturbations could have diverted fragments. Ground-based radar networks are sweeping through potential coordinates, listening for faint reflections that might reveal its new location. If these efforts yield nothing, if 3I Atlas has truly disappeared without trace, we will face questions that reach far beyond astrophysics. Could an object truly conceal itself from detection? Could it possess materials or structures that minimize reflectivity across the electromagnetic spectrum? Could it have maneuvered so dramatically during perihelion that it now occupies a region of space we have not yet considered? Or, perhaps most unsettling of all, could the disappearance be exactly what it seems, an intentional departure, executed precisely when observation was impossible, leaving behind only questions and a haunting sense that we may have just witnessed intelligent action? Whether 3I Atlas proves to be natural or artificial, whether it disintegrated or departed deliberately, one fact is undeniable. It has already transformed our perception of the cosmos. It has forced humanity to confront the limits of our understanding. It has reminded us that the universe owes us no consistency, no predictability, no comfort. In just 8 years, we have encountered 3 interstellar visitors. The first accelerated mysteriously, the second behaved unusually yet conventionally, and the third decelerated impossibly before vanishing completely. That is not random chance, that is escalation. And if something or someone is attempting to draw our attention, this would be the exact sequence to do it. Right now, somewhere in the silent gulf between worlds, 33 billion tons of matter that we tracked only weeks ago exists somewhere we cannot identify. Either we have profoundly misunderstood the physics that govern interstellar travel, or we have witnessed technology in motion. In either case, our understanding of the cosmic neighborhood has changed forever. The truth will emerge eventually, it always does, but until that moment arrives, we stand at the edge of the unknown, forced to consider the possibility that something beyond our solar system came here, observed, and then departed entirely on its own terms. And perhaps the most terrifying revelation of all is not that 3I Atlas disappeared, but that we are finally beginning to grasp just how little we truly know about what moves through the dark expanse surrounding our fragile blue world.